Previously, we looked at how to write a condensed structure or condensed formula from a skeletal structure. Now we're going to look at how to turn a condensed structure into a skeletal or Lewis structure. As we did when we were writing our condensed structure, we went one atom at a time. We're going to do the same thing in trying to get back to a Lewis and skeletal structure of a compound. First, we write our carbon with 3 hydrogens. We see that is attached to a carbon with 2 hydrogens, which is attached to a carbon with 2 hydrogens, and then a carbon with 3 hydrogen atoms. So these two structures, shown in very different ways, represent the exact same information. We can also write this as a skeletal structure, but it's usually easier to go from the condensed structure to the Lewis structure before we write the skeletal structure. When we look at our Lewis structure, we see we have 4 carbon atoms with single bonds between them, so we can then draw the skeletal structure, which shows 3 line segments representing each of those bonds and our 4 carbon atoms. Let's look at another example. We start with our CH3, then CH, CH, C, CH. As we look at our carbon atoms, what we see is that we have carbon atoms that do not form 4 bonds. We cannot add more hydrogen atoms. Unlike a skeletal structure where we add enough hydrogens until we have 4 bonds because they're implied hydrogens, the condensed structure actually shows us what we have. And because we only have a certain number of hydrogens, that's the only number of hydrogens we can put in our structure. The way we get to having 4 bonds is because we have multiple bonds in here. So some combination of double and or triple bonds that give each carbon atom 4 bonds. So if I look at these 2 carbon atoms, we see that each only have 3 bonds. If there was a double bond between these two, then each carbon would have 4 bonds. So we can see that we have to make a double bond to make this a reasonable structure. We look at the next carbon atoms and we see that they only have 2 bonds. And so adding 1 to make a double bond will not be sufficient. And so we're actually going to make that a triple bond in order to have each carbon with 4 bonds. So now our Lewis structure represents what we have seen in our condensed structure. We can also draw a skeletal structure from here. First, by drawing the basic structure with 5 carbon atoms, and next drawing in the double bond between the second and third carbons, and the triple bond between the fourth and fifth carbons. In this condensed structure, we're going to see how we handle side chains in a molecule. So we start with our CH3, then we have a CH, but we also have an OH group off to the side because it's in the parentheses, so we know it's not in the main chain of the molecule. Then we have CH2. Next, we see an oxygen that's not in parentheses, so we know that the oxygen is part of the chain. Then we have CH2 and CHBr. Remember that halogens are just like hydrogens in that they only form 1 bond. So halogens are not put in parentheses even though they are off to the side of the molecule. We treat halogens just like we treat our hydrogen atoms. And then we have a CH3 as well at the end. We can draw this into a skeletal structure where we have 3 carbons and then an oxygen and then 3 more carbons. And then we can go back and place the OH group on the second carbon from the left, and then place our bromine on the second carbon from the right. So all 3 of these structures show us the exact same information in different ways. This is another example of how we deal with side groups listed in the condensed structure. So we start with our CH3. And then we have a carbon which has 2 CH3 groups attached, and then a carbon with a CH2 CH3 group attached, and a carbon with a hydrogen, and a carbon with 3 hydrogens. As we look at this structure, we also see that we have some carbon atoms that do not have 4 bonds. As a result, we need to put in multiple bonds in order to make sure each carbon has 4 bonds. So we'll need a double bond between the third and fourth carbons in the backbone of the structure. We can also draw this as a skeletal structure, first by putting our 5 carbon chain that forms the backbone. The second carbon will have 2 CH3 groups off of it. Unlike the OH or the bromine, notice that we don't have to show those atoms because the end of those lines represents a carbon and the hydrogens are implied. On the third carbon, we have a CH2 and a CH3, and those are all in one group off to the side of the molecule. And then we can show our double bond between the third and fourth carbons.